In the complex world of human relationships, our choices in romantic partners are far from random. Recent neuroscientific research has revealed fascinating insights into how our brains influence our romantic attachments, from childhood experiences to adult relationships. This article delves into the neurobiological underpinnings of love, attachment, and partner selection, offering a scientific perspective on the age-old question of how we choose our mates. The roots of attachment, from childhood to adulthood. One of the most groundbreaking discoveries in relationship science is the strong link between our childhood attachment patterns and our adult romantic relationships. Neuroscientists have found that the neural circuits responsible for infant caregiver bonds are repurposed in adulthood for romantic attachments. The 4 attachment styles. Researchers have identified 4 main attachment categories that begin in childhood and often persist into adulthood. Securely attached, insecurely attached, anxious avoidant, resistant insecure, anxious ambivalent, disorganized disoriented. Remarkably, a child's attachment style as a toddler is strongly predictive of their attachment style in romantic partnerships later in life. This continuity underscores the profound impact of early experiences on our lifelong relationship patterns. The neurobiology of attachment. The persistence of attachment styles from childhood to adulthood is rooted in our neurobiology. Our brains are hardwired for attachment, with dedicated neural networks and hormonal systems ensuring we respond to caregivers' presence or absence. This same circuitry later influences our responses to romantic partners, shaping our expectations, behaviors, and emotional reactions in adult relationships. The dance of autonomic nervous systems. When 2 people engage in the mating dance, whether during a dinner date or in more intimate settings, their autonomic nervous systems engage in a coordinated activity. This subtle interplay involves a brain region called the insula, which allows us to pay attention to our internal bodily sensations, interoception, while also monitoring external cues from our potential partner, exteroception. The role of the insula. The insula plays a crucial role in romantic interactions by monitoring our own bodily sensations and thoughts, assessing our partner's comfort level and focus, facilitating the coordination of autonomic responses between partners. This neurobiological dance underlies the often unspoken communication that occurs during romantic interactions, influencing our perceptions of compatibility and attraction. The malleability of attachment patterns. While our early attachment experiences significantly influence our adult relationships, neuroscience offers hope for those with less than ideal attachment histories. The concept of neuroplasticity, the brain's ability to form new neural connections throughout life, suggests that our attachment patterns can shift over time. Changing attachment styles. Understanding the existence and malleability of these attachment templates is a powerful first step in changing them. By consciously working on our relationship patterns and seeking healthy partnerships, we can gradually rewire our brain's approach to attachment and love. The neurobiology of desire and mating. At a fundamental level, our brains are equipped with specific regions that control mating behaviors. The ventromedial hypothalamus, for instance, contains neurons that, when stimulated, can trigger mating behaviors in animals. While human mating behaviors are far more complex, this highlights the biological underpinnings of our sexual and romantic drives. The switches in our brains. Neuroscientists have identified various switches in our brains for different emotions and behaviors, including love and rage. While individuals may vary in their propensity for these feelings, we all possess the basic circuitry for a wide range of emotional responses. This understanding can help us navigate our own emotional landscape and that of our partners with greater empathy and self-awareness. The neuroscience of breakups. From a neurobiological perspective, breakups can be as traumatic as physical pain or grief. When a relationship ends, our brains must adjust to the absence of the partner in time and space. This process is akin to withdrawal from an addictive substance, explaining the intense craving and distress many people experience after a breakup. The challenge of modern technology. Social media and digital communication have made the process of letting go after a breakup more challenging. Constant access to information about an ex-partner can prolong the brain's adjustment period, making it harder to move on. Understanding this neurobiological reality can help individuals make healthier choices during the recovery process. Creating healthy relationships. a neurobiological perspective. Armed with these insights from neuroscience, how can we foster healthier, more fulfilling relationships? Here are some key takeaways. Self-awareness is crucial. Understanding your own attachment style and emotional patterns is the first step towards healthier relationships. Focus on mutual care. Relationships thrive when both partners prioritize taking care of each other and themselves. Recognize power dynamics. Some relationships work better with clear leadership roles, while others thrive on mutuality. Understanding what works for you and your partner is key. Be brave but maintain boundaries. Successful relationships require vulnerability, but it's equally important to maintain healthy boundaries. Understand the role of routine. Long-term relationships become part of our daily routines. Being mindful of this can help in creating sustainable partnerships. Practice open communication. While being cautious about the questions we ask, open and honest communication is vital for relationship health. Recognize the impact of early experiences. Acknowledging how childhood experiences shape our adult relationships can lead to greater empathy and understanding. Embrace neuroplasticity. Remember that our brains can change. With effort and awareness, we can develop healthier attachment patterns over time. Manage breakups wisely. Understanding the neurobiological impact of breakups can help in developing healthier coping strategies. Be mindful of technology's impact. In the age of social media, be aware of how constant digital connection can affect relationship dynamics, especially during breakups. Conclusion: the complex neurobiology of love. The neuroscience of love and partner selection reveals a complex interplay of childhood experiences, neurobiological systems, and conscious choices. Our brains are wired for attachment and love, with neural circuits that span from our earliest caregiver relationships to our adult romantic partnerships. Understanding these neurobiological underpinnings can empower us to make more informed choices in our relationships. It reminds us that while our past experiences significantly shape our romantic tendencies, we have the power to influence our attachment patterns through self-awareness and intentional actions. As we navigate the complex world of relationships, this scientific perspective offers both insights and hope. It shows us that love, with all its joys and challenges, is deeply rooted in our neurobiology. By understanding these processes, we can approach our romantic lives with greater wisdom, empathy, and the potential for more fulfilling connections. In the end, while science can illuminate the mechanisms behind our romantic choices, it also highlights the beautiful complexity of human relationships. Love remains a deeply personal and often mysterious experience, one that continues to captivate and challenge us, even as we unravel its neurobiological secrets.